Okay, so before we really talk about the problems that you're going to be doing today, I kind of have to do a setup with a lesson. So let's review. If you guys could remind me, what is a function? Oh. Yeah. Special relation where every input has one output. Every x maps exactly to one y. And so, for example, if I had the function f of x equals x squared plus 3. All right, we know if we graph this, or we should know if we graph this, it would look like this. How would I know graphically that this was a function? We have what's called the vertical line test. Every time I draw a vertical line, it only intersects with the graph one time. Okay, but forget about graphically. Like algebraically, what does it mean that this is a function? Okay, well, let's just pretend like I picked an input 2 for x. What happens if I plug 2 in for x? 2 squared is 4. 4 plus 3 is 7. I plug 2 in, I got a 7 out. Can I ever plug 2 in and get something else out of this function? No. It's always 7. It's never anything else. Okay? So, what's an example of something that would not be a function? All right, if I had...
equals 7 and 14.
Right, if I plugged in 2 and sometimes I got different things out. That's a good enough example. I don't have to give you more. We understand that. Every input maps exactly to one output. Okay, now let's talk about our trig functions that we've looked at so far. We've had things like f of x equals sine of x. All right, keep it simple to start with. What if the x I plugged in was pi over 4 radians, or 45 degrees? If I plugged in pi over 4, sine of pi over 4 is radical 2 over 2. Always. Can I ever get anything else out if I plug in pi over 4? It's always radical 2 over 2. There is no other correct answer. That's the only thing that it could be. Sweet. Now, what do I want to talk about next? Let's talk about how the sine function works. And here's what I mean by that. How the sine ratio works. We typically take sine of an angle, and it gives us a ratio of the opposite over the hypotenuse. Right? That's how sine works. For cosine, we normally take cosine of an angle, and it gives us the adjacent over the hypotenuse. We take tangent of an angle, and it gives us the opposite over the adjacent. My point is, we do trig functions of angles, and the result is a ratio. We've had problems where we didn't know the opposite. And so what did we do? If we knew the angle, we knew the hypotenuse, but we didn't know the opposite, we would put that over 1, cross multiply, and solve. We've had problems where we didn't know the hypotenuse. Same thing, over 1, cross multiply, solve. What we haven't worked on yet are what happens when we don't know the angle. I take sine of some angle, I don't know, but I do know the ratio. So let me give you a very real example. Say that I wanted to take sine of some angle. I don't know what it is. But it results in radical 2 over 2. What is theta? Okay, so in radians it's pi over 4. Is it always pi over 4?
No, it can be changed by the period.
Which quadrant are you
So what else would give me radical 2 over 2?
in?
Wrong question. Good thought. So right here, if I was looking for theta, I could say, well, theta might be pi over 4. Or it might be 3 pi over 4. It can't be 5 pi over 4 because it would be negative there. It can't be 7 pi over 4 because it would be negative there.
There's a positive version of it.
Not for sine.
Oh,
Sine's
yeah.
never positive. Doesn't work so well with a function, does it? Like I can't solve inverse. I can't solve for what theta might be without some rules. Because there's too many answers, right? I couldn't list them all. So I need to set up a set of rules that will allow me to only get one answer. Because I really like functions. Functions are really cool. And if I can always get the same answer, that makes my life a lot easier than having to worry about the other situations. Sorry, I kind of got sidetracked. I kind of didn't do exactly what I planned to do. I didn't want to talk about this yet. Okay? This is true. I talked about it. We're good. I'm going to skip that in a second. Let's get back to this. Okay? What would happen if I had to try to isolate the angle? Like, I told you how we find opposite. I told you how we found hypotenuse. How can I get the angle isolated? Divide by what? Divide by sine? Is sine multiplying the angle? No. So I don't divide. Do what? Oh, okay. So the way we undo things is we always do their opposite. If I had x plus 5 equals 10, the opposite of adding 5 is subtracting 5. If it was being multiplied by 3, I would divide. If it was being squared, I square root it. Right? Those are inverse operations. Well, the inverse of sine is called the inverse of sine. Or in some older textbooks, they might call it arcsine. A-R-C-S-I-N. You have arcsine, arccosine, arctangent, or the inverse of sine. The inverse of cosine, inverse of tangent. But those mean the same thing. Your calculators will show this. I don't remember what my open math does. But I go back and forth on what I say. Does it do both? Okay. It seems like the newer notation is inverse of sine. If you go read older textbooks, they're all arcsine, arccosine, arctangent. So they kind of have swapped that. So, what is the inverse sine of sine? Well, what happens when you add 5 and subtract 5? They cancel. What happens if you're multiplying by 2 and you divide it by 2? It cancels. What happens if you take the inverse sine of sine? Most of the time. We'll just say it does. Okay, so the inverse sine of sine cancels out. And I'm left with the angle equals the inverse sine of the opposite over the hypotenuse. So this is the point I want to hammer home right here. We take the sine of angles. We take sine of angles. We take inverse sine of ratios. Opposite over hypotenuse. Okay? So people just, I know what y'all do on y'all's calculator. Y'all just pick one. If it don't look right, you just do the other one. Right? I mean, y'all never really thought about which one you're supposed to use. You take sine of angles, always. Inverse sine has to be of the ratio, the opposite over the hypotenuse. And that's true for all of the trig functions, right? Cosine is of an angle. Inverse cosine is of a ratio. Okay, sweet. So now after I finish that, now let's just remember all of this conversation, right? Where I talked about all that. Let's build into that. So I want to make this 1-to-1. So in order, let me lead this discussion from graphically. Let's do it graphically. You can talk about it several different ways. But I guess since we just graphed sine, cosine, and tangent, I guess I'm going to do it graphically. So if I were to graph sine of x, this is not something you're going to have to redo. This is me explaining. I'm teaching right now still. If I graph the sine wave, this is what it is. And I want to have something that is the inverse of sine. Right? So sine is what's in x. I want the inverse of sine. So, do you guys remember how we find inverse functions? What do we do to find inverses? You started with ordered pairs. If I had ordered pairs that were 2, 3, 4, 5, 6, 7, is this a function? Yeah. Every input has one output. What's the inverse of this function?
3, 2, 5, 4, 5.
So to find an inverse, we change the x and the y's. We also do it graphically. If you remember graphically, we would reflect it over that line y equals x, which essentially just change the x's and the y's. So right here, okay, do y'all remember this? I think we talked about it in pre-cal. What was required in order to find an inverse? Y'all remember? The function has to be a special kind of function. I don't remember. That's okay. It's not. We don't spend a lot of time on it. This is really where it comes home. A 1-to-1 function. Y'all remember what 1-to-1 means? No, you don't. Okay, I'll just teach it. I'll just teach it like you don't know. To be a function, every input must have one output. Every x must have one y. That's a function. We looked at a parabola already. Is that a function? Yes. It's good. So, what are the normal points of our parent function here? -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Another type of function we could have had was the cubic function. -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Okay, these are functions. They're both functions. But only one of them is a one.
Teachers.
The progress
Miss
report.
Biddle has your progress reports ready. If you will send
Right here, my punchline.
7 through 12, I'm sorry, grade 7 through 12. If you will send one student up here to get those, please. Also, the Washington National Representative will be leaving today around 12:30. So if you've not seen him, try to go in there before 12:30 this morning. All right, thank you.
They're both functions. They both pass the vertical line test. But only one of them is a 1-to-1 function. Yes. To be a 1-to-1 function, every output must have exactly one input.
So it's the second.
So this one is a 1-to-1 function. This is not. Because think about if I inverted this. What would I be left with? I plug in 4, I get -2. I plug in 1, I get -1. I plug in 0, I get 0. I plug in 1, I get... Oh, so sometimes I plug in 1 and get -1. Sometimes I plug in 1 and get -1. Because the inverse will look like this, which would not be a function. So I can't take the inverse of a quadratic the way it is. You guys remember how we graph the inverse? What is the inverse of a quadratic? This is x squared. Square root. You remember what a square root graph looked like?
It's like
It looks like that, which is what? It's like
an R. Half.
it's like half of a sideways parabola. The graph should look like this, right? But we have said, hey, we really want this to be 1 to 1. So to make it 1 to 1, why don't we just like, ignored this half and only looked at this half, and I inverted this half. So I can restrict the domain. Because what am I not allowed to take the square root of? I can't take the square root of -2 or -1. And so what we did, I'm getting too much into the wrong side of this. Y'all follow that part, restricting the domain. Now it is 1 to 1. Look at the sine wave. I don't want to lose too much time. Well, I can keep going this way, but I don't want to. Look at the sine wave. Is it a function?
Yes.
Is it 1 to 1? So how can I make it 1 to 1? Yeah, if I could get rid of parts of it, then I could make it 1 to 1. But on the flip side, like if I cut it like here to here, right? Is it 1 to 1 there?
Yes.
Yes. But it doesn't include every possible value. Because sometimes sine is negative, right? So we want to try to get all values, but we want to do it where they're only there once. So what's the best way? What's the best way to get a 1-to-1 piece of the graph that does everything we need it to do? What if we went from there to there? Does that cover every y value? Do we go between -1 and 1?
Yes.
Yeah.
And it passes the horizontal line test.
It does pass the horizontal line test, so it's 1 to 1 there as well. So what are the input? What's my domain? This is negative pi over 2 up to pi over 2. Why couldn't I do the first and second quadrants? Why didn't I go 0 to pi? Why didn't I go here to here? Because sine was always positive there. I never get where sine is negative. Think about all students take calculus. Right? So, here's what we're going to say. Inverse sine is defined for negative pi over 2 to pi over 2. In other words, the first and fourth quadrants. So now, going back to my original question. Now that we know inverse sine is only defined for answers between negative pi over 2 and pi over 2. That restricts the domain to make us have a 1-to-1 function. I started by asking you sine of some angle equals radical 2 over 2. What was the angle? Well, if we had to solve this, we're trying to get theta by itself, right? So we would take an inverse sine of both sides. So what is radical 2 over 2? How much did I rotate to get positive radical 2 over 2? You see how this is between negative pi over 2 and pi over 2? Is this one? Is this one. It's too far to the left, right? So I've restricted, there were an infinite number of answers. That's why I couldn't make this a function. But I've restricted it down to say, hey, there's only one place this will work. Powerful. And now it works like a function, which is good, because you can type it in your calculator and it'll only give you one answer instead of an infinite number of answers. Could you imagine how? You don't care. Okay, so let's talk about where all of our inverse trig functions are defined. So inverse sine is in the first and fourth quadrants. Cool. What about inverse cosine? Inverse sine is first and fourth. Now I'm going to hijack my inverse sine function to talk about inverse cosecant. Because where do I get the cosecant graph from? Well, it comes from inverse sine here.
Why is this in?
Huh?
I don't like this one.
Oh, sorry, they didn't ask you.
I know, whatever place you can
Can y'all see the green? So where can I restrict it so I can get every possible answer? Oh gosh. Well, if I get one of these, right here it's not 1 to 1.
You gotta cut it.
You gotta go from
I need half of this and half of that one. Well look, that's already where inverse sine was cut. That's nice, isn't it? It's the same cuts. So inverse cosecant is defined in the first and the fourth. So inverse cosecant is 1 and 4. That's nice. It's the same as inverse sine because they're like reciprocals. That's so nice. They're going to make this so easy for us. That's so... Shh, quit ruining it. Okay. But I'm going to show you why. One asymptote in there. Correct. Right. And see, that one's inclusive. I don't know. Does it say? That's a good point. Inverse cosecant. The range is from negative pi over 2 to pi over 2. So like they don't cut out the vertical asymptote for inverse cosecant. You know like how they did on both of the tangents? I'm just curious. Why don't we just make it first and fourth? You don't know?
Because it can't be first and fourth.
Why?
Because it's positive in the fourth quadrant.
Oh, cosine's positive in the fourth quadrant?
Yes.
Oh. So right, if I take that same slice, do I get all possible values? See, I only get the positives. So inverse cosine can't be first and fourth. So where would you slice it?
First and second.
Looks like a good slice, right? So, inverse cosine is defined between 0 and pi. In other words, the first and second. Huh? You weren't asking me a question.
No.
Okay.
Why is over 1 left on this, the fourth quadrant? Because you're starting from 0, basically. You said the fourth quadrant, it's that. Because you're starting from 0, it's the closest negative. Like it's the closest if you go up.
Yeah.
And then that's the third.
Yeah, so like we could have made inverse sine work between 0 and pi over 2 and 3 pi over 2 to 2 pi. But then it's disconnected and it's not continuous and that's not what we're really looking for. We want it to all be cohesive.
So is the
Continuous.
third quadrant left of the fourth quadrant right there?
Yeah, this will be the third. Right, this is negative pi over 2. So if you rotated that, this is the third quadrant, second, back to the first. Right, because this is the same as. It's repetitive. We follow this. Do you have this note? These are the important notes. Like you don't have to be able to regraph this, but you've got to know where they're defined for. And it's probably in your notes somewhere. Okay. I don't look at the notes. Okay, it's at the very top of page 2. Okay. It's all right there. So you don't have to write it down if you'll just look there. Inverse cosine was in the first and second. Yeah, don't have. Okay. Let's do the same thing here for inverse cosine. Well, the reciprocal of inverse cosine would be inverse secant. If I were to graph it, we would be here, here, here. This looks worse. Luckily, I did a good job on the first one.
So it's first and second.
Right, so if I cut it,
It's like cosine.
right, it works just like inverse cosine. If I cut it here to here, I get half of that parabola and half of this parabola. Right, which is what I want. That cuts it, makes it 1 to 1. So just like inverse cosine is in the first and second, inverse secant is in the first and second. Everybody follows that? Good to go? If I'd be a real teacher and like prepare ahead of time, that'd be something. I just wing it. However I feel that day. I was feeling like a Mickey Mouse shirt, so this is what we're going with. This is how we roll. It's good. Next, let's look at tangent. All right, that's a tangent graph. Where would you cut this to be?
4 to 1, or 1 to 4.
So like right here's a vertical asymptote, right? And then there's the next one. So we would go from right, inverse tangent is from negative pi over 2. I'm interested in how they write this. To pi over 2, do they have inclusive on one end? I think it's supposed to be like that. Because if you include here, this is where it's undefined. And if you include here, this is where it's undefined. Right? And so I think we need one of them included. Maybe we don't, I don't remember. Because this is a very real ratio you can get with tangent, which is undefined, but you can't put it in your calculator. Like your calculator just break if you do this. I think it will never work again. So don't type it. No, I'm just kidding. But this point really exists, right? Where can I rotate to that gives me undefined? Well, if I put inclusive, it could be here or here. Well, I don't want two possible answers. That's what I'm trying to avoid. Well, if I don't include either one of them, then there is no answer. That's where I rotate to. So I'm pretty sure, and I could be wrong. This is a very rare case if you're going to have a question that does that. But I think it includes pi over 2, but doesn't include negative pi over 2. It doesn't matter. You're probably not going to have a question like that. There'll probably be. The important part is it's in the first and fourth quadrants, right? Between that, look, you can't tell what that is. That's garbage. First and fourth quadrants for inverse tangent.
What was inverse cosine?
All right, let's be neater on this one, Cody. So inverse cotangent, it's just going to be the same as inverse tangent. And oh, no, it's not. I'm getting there. Just give me a second. I can't graph it on the same one. It doesn't work the same way. Right? Let's try to line them up where they're the same places.
Are you kidding me? It's not that easy. But it's easy.
Yeah, but at least I'm not just telling you what they are. I'm explaining why. You don't care. You just want it to be easy.
No, I don't understand.
It's not just you. I'm being mad to everybody. Everybody just wants it easy. They don't care the why. So this is inverse cotangent. Well, if I look at inverse tangent, we decided to cut it from here to here. So could I technically cut it in the same place? You could, if they would have, you could, but it's so weird to look at like that, right?
No,
But you do get every possible.
that's perfect.
I agree, but they didn't do it that way. And I was not there when they made the decision. They cut it from here to here. Mr. Math. Oh, you had to be there when it's discovered. You discover it, you get to do whatever.
I mean, I guess that's really.
That's the way it's always been in history. Problem is, there's not as much to discover anymore. You can't just go find empty land like they could back in the. You could, yeah, you could try to go deeper, I guess. You could claim some of that. Inverse cotangent is in the first and second quadrants. It's between 0 to pi. That's probably how they did. They probably put parentheses on both of them, didn't they? Yeah, maybe I'm wrong, but I'm pretty sure you got to have one of the asymptotes. We'll see as we work. This is one I don't feel as confident about, so yeah. I'm human. Without using. This could be one of those tests that I don't even let you have a calculator the whole time. How would you like that? Oh. I probably won't do it, but I could. Okay. Looking here, inverse sine of -1/2. Without a calculator. Without a calculator. So what do I know? This is a ratio of the opposite over the hypotenuse. Where is inverse sine defined for? 1 in 4. I have to have where sine is positive and negative. Right? That would be in the first and the fourth. You can't go first and second because it would only be positive. So it's now I've got the positive and the negative. Because the ratio is negative, I know I'm in the fourth quadrant. I'm looking for this angle. Sine is a ratio of the opposite over the hypotenuse, which means this is a 1, radical 3, 2, which is a 30, 60, 90, which means, I'm assuming it's in radians since it doesn't tell me otherwise, 30 degrees in the fourth quadrant would be a -pi/6 rotation. Because it's only defined between -pi/2 to pi/2, where it's continuous. So this time you're actually going to rotate the negative direction to get to the fourth quadrant.
Hey, can you do the inverse of sine if you don't even know like the range and stuff? Because we're doing this in Miss Ferguson's and we're having a test today and she didn't tell us anything about the
You have
range.
2 math classes?
Yeah.
Yeah, you could probably do it because you should probably put it in your calculator, right?
Yeah.
But if I didn't have a calculator, this is the y. If you type that in your calculator, inverse sine of -1/2, it would spit this out. Make sure it's in degrees because you'll probably want the degree answer because this will be ugly in radians, right? You're gonna get some ugly, I don't know, -0.5. I don't know what it is. If you put it in degrees, you'll get -30.
Negative 30.
Is it exactly negative? No, it's
It's negative 0.5235.
Right, because, I mean, this is 3. This is 3/6, which is a half. I mean, I'm not some math genius up here. It's just a little more than a half is how I was saying. Okay. He wanted to know what it was in radians. Just ignore that. So yeah, you like all that backstory. You probably didn't have to know that, but I always like to understand the why. I don't just like being thrown. Do this and then do that and then do. That's just not my. I need the whole. Look, I'm probably on the spectrum. Okay, it's okay. So from here, if I go the arc cosine of 1. So this is the same thing as the inverse cosine, right? They're just using arc cosine. Well, first thing I need to figure out, where is arc cosine defined? It's in the first and the second, right? It can't be first and fourth because it would always be positive. So it's defined here. Well, this is one of those special cases, right? This is a special case because think about if I tried to make this a ratio. Where is the adjacent side 1 and the hypotenuse is 1? Not on any right triangle I ever know, right? So this is rotating to an axis. Well, cosine is the x value. So I'm looking for, where was the x value 1? It's right there if I rotated nowhere. 0. Ain't that cool? Yeah, it's 0. Can't you see how like we go from -1 to 1 on the x-axis? Making it 1 to 1. It's just so, I don't know, it feels so cool. Where I define it this way, I don't ever repeat x's. And then if you go arc sine, which is the y value, you do here, you never repeat that. That doesn't matter. Just had all ties together. It's just so cool. It's not just random. People had a reason they made all this junk happen.
Technically, could somebody say this is wrong?
Why? Because they needed to. That's why. What do you mean?
Couldn't imagine a mathematician just come a lot and say this is wrong.
Yeah, but this has been backed up over and over and over. It's very unlikely to be disproven.
You don't think you can prove it wrong?
No. No, I'm not smart enough. So from here, if I look at the inverse cosine of -1/2, inverse cosine is defined in the first and second. Because this ratio is negative, I know I'm in the second quadrant. Cosine is a ratio of the adjacent over the hypotenuse, which means my missing side would be radical 3, which means this angle is 60, which means I rotated 120 in degrees, which is 2 pi over 3 in radians.
Wait, how do you know you rotated?
Because I need 60 degrees in the second quadrant.
Oh, okay.
Hey, remember when I spent all that time at the beginning, I told you, hey, it's not going to go away. Hey, you're going to keep using it. Hey, it's never going anywhere. Hey, it's back. Hey, it's going to be back again and again and again and again.
This is cool.
I mean, I told you. I told you. What about it?
You will not
What's in
see
calculus?
Cal 1 classroom.
No. It's its own branch. There's a little bit of trig in Cal 1, but it's not. It doesn't build on this.
What does it do?
Because let's keep going. Yeah, we probably have. I'll teach you about anything. If I've got the inverse tangent of 0, where is inverse tangent defined? Inverse tangent. Thank you. Appreciate it. Here's y'all's progress reports if y'all want them. Your progress reports. I will get them as they're leaving. Inverse tangent is defined in the first and the fourth quadrants. First and fourth. So I'm here. Well, this is a ratio of the opposite over the adjacent. In other words, tangent is the y over the x. Well, this is a special case. Because the x value should be 1, the y value should be 0, which is here. Which means how much did I rotate? Remember, your answer every time is how much I rotated. Inverse tangent, arc sine, arc cosine is all about, I'm giving the ratio inside the argument and I'm looking for the angle that I rotated. So I rotated nowhere to get there. Arc cosine of 1/2. Cosine is the adjacent over the hypotenuse. Because this is positive, I'm in quadrant 1. Adjacent's 1, hypotenuse is 2. This is radical 3, which means that's a 60-degree angle, which means how much did I rotate? 60 degrees or pi over 3 radians.
So it doesn't matter if we put degrees or.
Just read. So all of these directions are telling me radians. You'll probably have some on my open math that ask you for degrees. Some ask you for radians. I personally, I would ask you for radians if it were me, and I would make you type this in. Because that's proven to me you can do it without a calculator. Because if you get some bogus 1 point, whatever this is, radians, I know you didn't do it without a calculator. So like on your Canvas test, if you type that in, I'm probably going to count it wrong. Because it's supposed to be done without a calculator. And so I should see exactly pi over 3. Not that, whatever your calculator will give you. Okay?
Wait, why?
Huh?
That was like
Why do we need to calculate in this class?
Yeah, 1 point. Exactly. That's the same place I'm at. 1 point something.
We never get to use our calculators. when we-
You shouldn't. You can do it without it. Arc tangent is -1. For this one? I don't care. Okay, so arc tangent is negative. I'm in the first and the fourth quadrants. Because it's negative, that puts me in the fourth. When it's tangent, I can write it as 1/1. That's okay because this is the opposite and this is the adjacent. So if I drew a triangle where the opposite was 1, the adjacent was 1. This is that secondary 45, 45, 90, right? The 1, 1, radical 2. The one I don't use by default. But I have to kind of know it. I can still see it here, right? It's the 1, 1, radical 2. At worst, you should know this is a right triangle that is isosceles, right? Has equal sides. That's always a 45, 45, 90. There's no other one it could be. Which means this angle is a 45-degree angle. Which means I've rotated negative pi over 4 radians. Isn't that cool how it all just fits? I mean, it's just... I don't know. I'm a nerd. Next, arc sine. Arc sine of 0. Arc sine is defined for the first and the fourth. Well, this one, the ratio is not going to make any sense. So I'm just thinking from the first and the fourth, sine is the y value. So where is the y value 0? Here, which is here, which means I'm here, which means how much did I rotate? None. 0. Arcsine is 1. Again, this is a special case, so I'm just going to use the same drawing. Sine is the y value. Where's the y value? 1 up here. I've rotated pi over 4.
So sine and cosecant is the same. Cosine and secant is the same.
That's they're in the same quadrant. You're talking about the arc.
Yeah.
The inverse functions are defined for the same quadrants. Sine and cosecant, cosine and secant, but not tangent and cotangent.
And yeah, that's what I was about to say. Tangent.
Did y'all get this one? 30 degrees in the second quadrant. This should be 5 pi over 6. Can I do without drawing it out? It's 30 degrees. Inverse cosine is 1 and 2. Negatives in the second.
Jack said that he was going to Chattanooga.
Did you want your progress report? Here. Okay, so starting here, we've got to find the inverse cosecant of negative radical, or negative 2 radical 3 over 3. Okay. So because this is inverse cosecant, that's the reciprocal of inverse sine. Inverse sine is defined for the first and the fourth quadrants. So inverse cosecant would be defined for the first and the fourth quadrants. Because this is negative, I'm in quadrant 4. Sine is the opposite over the hypotenuse. That means cosecant is the hypotenuse over the opposite. So this would mean the hypotenuse is 2 radical 3. The opposite side is 3. Is this a triangle we have memorized? No, not in this form. However, we are used to the 2 triangles we have memorized having a hypotenuse of 2. But what's different between 2 and what the hypotenuse is here? What's being multiplied by radical 3. So why don't I just divide everything by radical 3? Because that will keep the ratio the same. So this 2 radical 3 over radical 3, that's the same thing as 2. So now maybe this will be a ratio I'm familiar with. What is 3 divided by radical 3? It's just radical 3. You could think about 3. 3 is radical 3 times radical 3 over radical 3, right? Just rewriting 3 as this. And then I can cancel out a radical 3. It's like I'm unrationalizing the denominator, right? That's kind of what they had done to get in its current form. Which makes this one 1. Which means my reference angle is 60. Which means in radians, how much did I rotate to get 60 degrees in the fourth quadrant? Negative pi over 3. Glad you missed Friday? So it's all just going to be which quadrant I'm in. Inverse cotangent is defined for the first quadrant and the second quadrant. Inverse tangent is 1 and 4. Inverse cotangent is 1 and 2. They're the ones that don't agree with each other. So, looking at the one up top, because my argument is positive, I know I'm in the first quadrant. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So this would be the adjacent over the opposite, which means my adjacent side is 1, my opposite side is 1. Which means the hypotenuse is radical 2, which means this is one of the 45, 45, 90s, which means I've rotated pi over 4 to get there. Now, inverse cotangent is negative. That puts me in the second quadrant.
So it's like, one is yes, and the other one's no. It's like
Sure.
first and
Yeah, absolutely.
it has two options.
This is the adjacent over the opposite. So my adjacent side is 1. My opposite side is 1. This is also radical 2, which means this reference angle is 45, which means how much did I rotate to get 45 in the second quadrant?
Wait, can it all be a 1 or a -1 in that?
But look back at all the ones we had before. If I look here, I've got the inverse secant of -2. As I'm thinking, inverse secant is the reciprocal of cosine. Inverse cosine is defined for quadrants 1 and 2. So if inverse cosine is in 1 and 2, inverse secant is in 1 and 2. Because the argument here is negative, I know I'm in the second quadrant. Cosine is a ratio of the adjacent over the hypotenuse. So secant would be a ratio of the hypotenuse over the adjacent, meaning the missing side is radical 3, meaning my reference angle is 60, meaning I've rotated 2 pi over 3 radians to get there. Like a function inside of a function, f of g of f, g of f of x, not Fogg and Goff, which I'd have to say, because that's all y'all remember is Fogg and Goff. Yeah, there we go. So that's what's happening here. I'm going to take the sine of the inverse cosine of 5 over 13. So what I want to review here very quickly is remember what it is we're doing. We take sine of an angle. Right? So this garbage is just an angle. And if I can take sine of that angle, I should get the opposite over the hypotenuse. Same thing here. I'm going to take tangent of an angle to get the opposite over the adjacent. So just with that in mind, that's my goal. I'm going to start with the inside of the composition, looking at the inverse cosine of 5 over 13. So we can do that. That makes sense to me. The inverse cosine of 5 over 13. Inverse cosine is defined for quadrants 1 and 2. Because it's positive, I'm in the first quadrant. Cosine's a ratio of the adjacent over the hypotenuse. So the adjacent's 5, the hypotenuse is 13. So how much did I rotate? Great question. Is this one of the triangles that we know? Do we know this? Okay. We may know the sides to it. We don't know that angle. Right? I have no idea what that angle is. But I'm going to call it theta. Because how much did I rotate? That amount. I rotated that much. How much did I rotate? This one. So now, can I find sine of this? Well, sine would be the opposite over the hypotenuse. Can I find the opposite? One of 2 sides of a right triangle. I can find the third side by, not you, Brandon. I can find the third side by the Pythagorean theorem. Or, Brandon, you could tell them that it's a special right triangle. I'm sorry, it's a Pythagorean triple, right? It's a 5, 12, 13 Pythagorean triple. It's 3, 4, 5, 5, 12, 13. Here's the 5, 12, 13. Now, because I know the missing side, I can find sine of this angle. I'm in the first quadrant, so sine should be positive. Sine is the opposite over the hypotenuse, 12 over 13. You want to try the bottom one, or you want me to do it? All right, I'll give you a 60-second head start. Okay, I'm taking the inverse sine of 12 over 13. Inverse sine is defined for the first and the fourth quadrants. Inverse sine is in 1 and 4. Because this is positive, I'm in the first quadrant. Sine is the ratio of the opposite over the hypotenuse. So I'm looking for the angle I rotated. Well, there it is. I rotated that much. So now can I find tangent of that same angle? Well, I can't. I just need to know the missing side. Well, this is a 5, 12, 13. Pythagorean triple. Because I'm in the first quadrant, it's positive. Tangent is the opposite over the adjacent. Okay, the cosine of inverse sine of radical 3 over 2. This is one that you could do without drawing a triangle, right? If you know, what's the angle that this would have to be?
30, 60, 90.
Yeah, but which angle is it? It's a 30, 60, 90. Inverse sine. So the opposite is radical 3. So this is 60. So then I'm finding cosine of 60. Well, cosine of 60 is
Opposite over hypotenuse.
a half. Adjacent over hypotenuse. That's bad that you ever looked at sign. That's not a good sign.
I just double checked myself.
Yeah, well, you were wrong. So
Yeah, double checked myself and realized I was wrong. Oh, I did.
So,
I've been trying.
Wait, it's got the angle.
Do I need to draw this one out, or do you guys follow what I'm putting down from here? You can draw it out, just like we did on the ones before. Or, because this is a triangle we know, you can do it a little quicker. Right here, what about tangent of the inverse sine of 0?
0.
Inverse sine of 0. So, sine is the y value. So, where's my y value? 0. It's there where I've rotated nowhere, so this is 0. So what's tangent of rotating nowhere? Well, tangent is the y over the x. 0 over 1, which is 0. The inverse sine of cosine of 5 pi over 3. So cosine of 5 pi over 3. So this one's kind of backwards from what we've been having. We have been doing the trig function of the inverse trig function. This is the inverse trig of the trig function. So we're going to rotate to 5 pi over 3 and find cosine of that angle. So 5 pi over 3 puts me in quadrant 4. This is a 60-degree reference angle. Opposite 60 is radical 3, 1, and 2. So cosine of this angle would be 1 over 2. And because I'm in the fourth quadrant,
It's probably just going to be.
all students take calculus, it's going to be positive. So what I'm really finding is the inverse sine of a half. You follow how this is just 1/2? Cosine of 5 pi over 3 was a half. So now if I had to find inverse sine of a half, inverse sine is defined in the first and the fourth quadrants. Because it's positive, I'm in quadrant 1. Sine is the opposite over the hypotenuse, which means my adjacent side is radical 3, which means my reference angle is 30, which means I've rotated pi over 6. It's a lot of steps, right? Again, while we went so slowly over all that at the beginning and just kept hammering it in. You better know it. You gotta know it. Hey, you can't fake your way through that stupid first test because it's not going away. Okay.
I didn't think like that.
So I'm taking the inverse sine of cosine of 7 pi over 6. I'm starting on the inside. Cosine of 7 pi over 6 puts me in quadrant 3. reference angle 30, 1, radical 3, and 2. Because I'm in the third quadrant, my answer is going to be negative. Cosine is the adjacent over the hypotenuse, which is radical 3 over 2. So now I'm taking the inverse sine of negative radical 3 over 2. Inverse sine is defined for the first and the fourth quadrant. Because this is negative, I'm in quadrant 4. Sine is the opposite over the adjacent. Sorry, opposite over hypotenuse. So the opposite is radical 3. The hypotenuse is 2. Meaning my missing side is 1. Making this a 30, 60, 90. So the reference angle is 60. Meaning I rotated negative pi over 3 to get there. The actual trig function. Let me tell you why there's a problem. Why these don't cancel out. Where's this angle? 7 pi over 6. That puts me in quadrant 3. If I take arc sine, it has to be in quadrant 1 or... Well, it's not 3. Right? If you can't remember it's 2 or 4, it is 4. It's not 3. So they can't just cancel out. I can't take arc sine of a ratio and get something in the third quadrant. It's not a thing. So these don't just cancel out. Sometimes they will. If this angle was in quadrant 1 or 4, it cancels.
Automatically?
Yeah. But if it doesn't, you have to think through the process to get in the correct quadrant. And you actually don't even have, we'll see if we can shortcut it in a second. But let's just think through it normally for now. Sine of 7 pi over 6 puts me in the third quadrant. This is a reference angle of 30, meaning this is a 30, 60, 90. Opposite of 30 is 1, radical 3, 2. Because I am in the third quadrant, sine is negative. Sine is the opposite over the hypotenuse, which would be 1/2. So what's in parentheses is negative 1/2. So now can I find the arc sine of negative 1/2? Well, arc sine is defined for quadrants 1 and 4. Just talks about it. Because the argument is negative, that puts me in quadrant 4. Sine is a ratio of the opposite over the hypotenuse, meaning my missing side is radical 3, meaning this reference angle is a 30-degree reference angle, meaning I rotated negative pi over 6 to get there. Negative 30 degrees or negative pi over 6. What did you put?
No, I just forget the negatives. Like I've done it with a few other ones too. Like I forget.
11 pi over 6.
Like I'll get like, for instance, like 1/2, and then you're like, oh, that's positive. Like,
Oh, right here.
Yeah, I just forget to put it.
So what can we say about these two? They're the same reference angle, right? This was in the third quadrant. Well, what was sine in the third quadrant? Negative. Well, I know I need to rotate to where it's going to be negative in the arc sine, which would be in the fourth quadrant. So it's the same reference angle, just in the correct quadrant to keep the sine the same. So, for instance, if this was in the second quadrant, then because because sine is positive, then I would need arc sine to be positive, which would be in quadrant 1. Or again, you can just think through it like this. You don't have to know that it cancels, doesn't. You can just know, hey, if it's arc sine, if the inverse is out here, it might cancel. But it might not. If the regular trig function is out here and they're the exact same, cancel. Okay, so here's the ones that 90% of the time are really great. But they're not always. Right, what do we do if we're taking the cosine of inverse cosine?
Probably just find cosine.
These are inverse operations. What happens when we square something and then square root it?
It's normal.
Just the same thing, it cancels out. If I add 3 and subtract 3, it
Oh, zero.
cancels out. So, just looking at this, 90% of the time this cancels out. Okay? But it doesn't always. And I don't know, I've not seen these two examples. So, let's just go through it and see if this is one that cancels out or not. So, I've got the inverse cosine of radical 2 over 2. Inverse cosine is defined in quadrants 1 and 2. Because it's positive, I'm in quadrant 1. In quadrant 1, cosine is the adjacent over the hypotenuse. Means this is radical 2, means this is 45. Which means I'm really finding cosine of 45 degrees. What is cosine of 45? Well, here's my triangle. Cosine is the adjacent over the hypotenuse. Because I'm in quadrant 1, they're both positive. So it's radical 2 over 2. So that's how they did. They just canceled right out. It's nice.
Yeah, but like, when do they not? I don't understand. that.
I'll come up with an example if neither one of these are. Okay?
Arctan.
I'll come up with an example.
Arctan is the same.
Tangent of the arctangent of -1. So I'm starting here. That's -1 over 1. Arctangent is defined for quadrants 1 and 4. Because this is negative, I'm in quadrant 4. Tangent is the opposite over the adjacent, which means if my opposite is 1, my adjacent is 1. This is radical 2, which means this is 45 degrees in the fourth quadrant. So I'm going to think about this as -45 degrees, right? So I'm finding tangent of -45 degrees. Well, if I'm going -45 degrees, that rotates me here. I draw my triangle. This would be the opposite over the adjacent because I'm in the fourth quadrant. Tangent is negative. So it would be -1 over 1, which is -1. So again, those canceled right out. I guess what I'm telling you is, if you're not sure, just act like they cancel out. Right? Because I'm telling you 90% of the time, they cancel out. Let's come up with one that doesn't. If I had to find the inverse cosine of cosine of 5 pi over 3.
One of them's negative. They're both negative.
Just write down 5 pi.
So here is on the front end how I could tell that this was not just going to cancel out. Where is this angle at? What quadrant? 4. Where's inverse cosine defined? 1 and 2. So I can't take the inverse cosine of something and get an angle in the fourth quadrant. It has to be in the first and second. So these won't cancel. Right? They won't cancel. It's going to put me in a different position. So let's just think our way through it. On the inside, what is cosine of 5 pi over 3? 5 pi over 3 is in quadrant 4. That's a 60-degree reference angle. 1, radical 3 and 2. Cosine is the adjacent over the hypotenuse, which would be 1/2. And because I'm in the fourth quadrant, it's positive. So I'm really finding the inverse cosine of 1/2. Right? Do we follow where I'm at so far? Inverse cosine is only defined for quadrants 1 and 2. Because it's positive, I'm in quadrant 1. So inverse cosine is the adjacent over the hypotenuse, which means this is radical 3, which means this angle is 60, which means how much did I rotate to get 60 in quadrant 1? So it's the same reference angle, it's just in the correct quadrant. Right? So that's the way you could catch it on the front end. If you think about, if I'm taking the inverse cosine of this, is inverse cosine defined for this quadrant? If it is, they'll cancel. If it's not, it's got to move to the correct quadrant. It can't give you an answer that's in a different quadrant.